For assignment number 13 for the warm-up number 1, the goal is to practice converting units because in order to find the arc length of a circle, it requires converting units. So a couple options in order to convert units. You can technically do this without showing any work. You can also create a table as shown here, or you can create two equal ratios called a proportion. So for part A, I'm going to create two equal ratios. So we're trying to figure out how many feet is in 3 miles. So the known conversion is that 1 mile is 5280 feet. It doesn't matter what I write in the numerator or the denominator. I chose to write miles in the numerator. However, in the second fraction, if I wrote miles in the numerator, I have to stay consistent. So 1 mile is 5280 feet. 3 miles is how many feet? That's what we're trying to find. So in order to solve this, you can either cross multiply, or if you could see equivalent fractions, you can do that method. So I know that I can multiply 1 by 3 in order to get 3. So if I multiply the numerator by 3, I have to multiply the denominator by 3. So 5280 times 3 would be 15,840 feet. So technically, all you really had to do to convert units was multiply 5280 by 3. In other words, instead of 1 mile, we want 3 miles, so I just multiply the right side by 3 as well. For part B, 45,390 feet is how many miles? So I'm going to use the same method where I create two equal ratios. The first is my known conversion. 1 mile is 5280 feet. So my numerator in the next fraction has to be miles. So I'm trying to figure out how many miles is 45,390 feet. So I'm going to cross multiply on this one. X times 5280 is 5280x, and that's equal to 1 times 45,390 is 45,390. One last step to isolate the x, divide by 5280. We're going to round to the nearest tenth, and if you round to the nearest tenth, you should get approximately 8.6 miles. So technically all you had to do was take 45,390 and divide by 5280. In order to convert without having to set up two equal ratios. Lastly, part C, we're trying to figure out how many questions you need to get correct in order to get a C on a test with 15 questions. So this one's already set up for you. We know that a C, the lowest C, is a 70 out of 100. So you're trying to figure out how many out of 15. So if I cross multiply, 100 times x is 100x. And if I multiply 70 times 15, I get 1,050. One last step is to divide both sides by 100. And so you get 10.5. So we're trying to figure out how many questions we need correct on a test. That has to be a whole number. So 0.5 means you need more than 10 correct. So technically you're rounding up here. So you need 11 questions correct on that test in order to get a C. For number 2 on the warm-up, our goal is to use that same method of setting up two equal ratios in order to find something called the arc length of a circle. So what is the arc length? Well, it is the portion of the entire circumference. So again, the entire circumference would be measuring all the way around the circle. But if you just want a portion of that, for instance, this arc here, AC, that would be a portion of the entire circumference. So technically, if you had a piece of string, you could cut the piece of string and measure from A to C by laying it on the circle and then taking that exact same string and laying it straight across and using a ruler to measure the length of that. So that's technically what our arc length would be. So in order to find the arc length, there's a couple things you need to know. For number 1, since the arc length is a portion of the circumference, we have to know the formula for the entire circumference. There's really two formulas that you can use. So either 2 pi r would be one formula, where r is the radius. Or if you double the radius, you get the diameter. So you could just use diameter times pi, where d is the diameter. So between these two choices, I'm going to choose 2 pi r when we actually fill in the two equal ratios at the very bottom here. The second thing we need to know is the arc measure in total of a circle. How many degrees is it all the way around a circle? 360 degrees. So in this picture, we are trying to find the arc length of AC. So from here to here. That is different than the arc measure. Arc measure would be degrees. In fact, we do know the arc measure of AC because the central angle right here is 84 degrees, and the central angle is always the exact same as the measure of the arc. So the measure of arc AC, that's degrees, would be 84. So if you look down at these two equal ratios, they are already labeled for you. The numerator represents the portion and the denominator represents the entire circle. So the first ratio is comparing arc measure. So how many degrees was AC? It was 84 degrees. How many degrees in total is a circle? 360. And that's equal to, now we're going to relate the circumference of a circle. We are trying to find what portion of the entire circumference AC is equal to. So that's our unknown. We don't know the length of AC, but we do know the entire circumference is 2 pi r. And in this case, in order to solve for our arc length, we do have to plug in what the radius is. So if you look at the picture, the radius is 12. So where that r is, I'm going to erase and fill in 12. For pi, we're going to estimate pi is approximately 3.14. So in order to solve for the arc length, we're going to be cross-multiplying. So 360 times x is 360x, and that's equal to, so there's a couple numbers we have to multiply here. 84 times 2 times 3.14 times 12. I get 6,330.24. We're going to round in the very last step. So the last step to isolate the x is to divide by 360. And here we're going to round to the nearest tenth. So if I divide that by 360, I get approximately 17.6. And they didn't give us units, so we're not going to attach units there. It could be inches, meters, centimeters, and so forth. So to recap what we did on the warm-up, we were able to find the arc length, which is a portion of the circumference, by setting up two equal ratios. The first ratio was talking about the arc measure, and the second was talking about circumference. So in the numerator of our first ratio, we're actually going to find the arc measure. And that's out of a total of 360 degrees. The second ratio is circumference, so we're trying to find what portion of the circumference, which is called the arc length, out of a total circumference of 2 pi r. So r is the radius, and pi we're going to use approximately 3.14. So this is the setup for every single question that's asking you to find the arc length. So for this next picture, we are given that EB is 15 centimeters. So from the center, E, to a point on the circle, that would be called the radius. That's 15 centimeters. So this is the radius. We're trying to find the length of CD. So I'm going to highlight CD. Notice that if there's no lowercase m next to arc CD, you're not finding the degrees of CD, you're finding its length. So let's go to our two equal ratios and start plugging in from the picture. My numerator of my first fraction, the arc measure fraction, I have to find the arc measure in terms of degrees. So how many degrees is CD? First of all, if it has two letters, it has to be less than 180. And there's some things I could label in this picture. If this central angle is 68, then the intercepted arc from arc BC is also 68. And I can use that in order to find the measure of arc CD. How? Well, I know that a half circle, which I'm going to highlight in blue here, a half circle is 180 degrees. This 180 degrees that I highlighted in blue is made up of two arcs, the 68 degrees and the unknown. So since those have to add to 180, I could just take 180 and subtract 68 from that in order to find the missing arc, which is 112. So the measure of arc CD is 112. And that's out of a total of 360 degrees for every circle. The next fraction, we're trying to find the arc length, which is a portion of the circumference. So x out of the entire circumference of the circle is 2 pi, and we're plugging in 15 for the radius. From here, we're just going to be cross multiplying and rounding our answer to the nearest tenth at the very last step. So 360 times x is 360x, and that's equal to, we have 4 numbers to multiply here, so 112 times 2 times 3.14 times 15 equals, I get 10,550.4. One last step to isolate the x, divide both sides by 360, and here we're going to round to the nearest tenth. So if you round to the nearest tenth, you get 29.3, and our units was centimeters. So CD is approximately 29.3. Notice I didn't put the little lowercase m in front of the CD because it's not degrees, it's length. For number 2, we're going to be doing the same setup in order to find the arc length of NMP. So they give us that NR is 8 feet. So from R to N, centered to a point on the circle, that would be the radius. So that's 8 feet. Now let's highlight NMP. So if it has 3 letters, it has to be more than 180 degrees. So I start at N. I have to pass through M next and land at P. So this would be NMP. So it's made up of 3 different arcs. So if I go to my setup here, I know my numerator of my first fraction has to be the arc measure. So looking at my picture so far, I only have 162 degrees, and then I have to find the 2 remaining arcs here, MN and QP, which would be identical because they're created by vertical angles here, the central angles. So there's a couple ways you could find this. So one thing I notice is that my blue arc that I'm creating here is 180 degrees because it's a half circle. So if this half circle in blue is created with 2 arcs, and I already know one of the arcs is 162, all I have to do is take 180 and subtract 162 from that, and that would give me 18 degrees. So I know that this arc is 18 degrees, and therefore MN is also 18 degrees. So now that I have all 3 arcs labeled, I can find my arc here, NMP. So again, in order to find this arc, I just have to add 18 plus 162 plus 18. So that would be 198 degrees. So 198 degrees is my arc out of a total of 360 for a circle. We're trying to find the arc length, so that's my unknown, out of a total circumference of 2 pi times the radius, which is 8. Then from here, we're just cross multiplying and rounding in the very last step. So x times 360 is 360x, and that's equal to, we have 4 numbers to multiply here, 198 times 2 times 3.14 times 8, 9,947.52. And lastly, if you divide both sides by 360 and round to the nearest tenth, I get approximately 27.6. So the units was feet. So arc NMP is approximately 27.6 feet. For the U-Try, I suggest pausing the video, trying this one on your own, and then replaying it to see if you got the same answer that I did. Alright, so we're trying to find the arc length of KJG. So they give us that JH is 21 inches. So if I look at my picture from J to H, that's not the radius this time, that's the diameter. So to get the radius, all I have to do is cut that in half. So take 21 and divide it by 2, in order to get halfway across, which is 10.5. So the radius is 10.5. If I highlight KJG, it should be more than 180 because it's 3 letters. So I start at K, I have to pass through J next, and end up at G. So it's almost the entire circle. So a couple things to notice. We know that JI is 85 because it's created with this central angle here. That's the same as the intercepted arc. And then GH is 59 degrees using that same process. So we still have 2 more arcs to find, created by these 2 vertical angles, right? And those arcs would be identical. Once we find those 2 arcs, we just add all 4 arcs because what I highlight in yellow is created by 4 different arcs. And that would give us our arc measure. So again, I'm going to look for half circles. I know that what I highlight in blue right now is a half circle, and it's made of 2 arcs, the unknown and then the 85. So all I have to do is take 180 and subtract 85 from that, which is 95. So my unknown arc here is 95. So if HI is 95, then KJ is also 95. Again, because they're created by the vertical angles here. So now all I need to do in order to find the degrees of KJG is add all 4 numbers together. So if you add 95 plus 85 plus 95 plus 59, you get 334 degrees. And that's out of 360. My second fraction, my arc length, what I'm trying to find out of a total circumference of 2 pi times the radius, which was 10.5. All right, so next we cross multiply and round in the very last step. So 360 times x is 360x, and that's equal to 334 times 2 times 3.14 times 10.5. 22,023.96. And lastly, if you divide both sides by 360, you get approximately 61.2. So the length of KJG is approximately 61.2 inches. And how did I know inches? The units for the radius was inches. For this last part, we're going to be answering a couple questions about a Ferris wheel. So here's some information about the Ferris wheel. It tells us the height, the diameter, rotation, speed, the location of where it's at in Japan, and the first time it opened in 1999. So our very first question is, how high is the Ferris wheel in feet? So they give us a known conversion. 1 meter is approximately 3.28 feet. So to convert, I'm going to use 2 equal ratios. My known is that 1 meter is 3.28 feet. So my next fraction, meters, has to be in the numerator. They give us how many meters it is. The height right here is 115. So 115 meters is how many feet? That's what we're trying to find. So from here, you could just cross multiply. So 115 times 3.28 is 377.2, and that's equal to x. So 377.2 feet. That's our first part. For part 2, we want to know the angle of rotation per minute. So what do they mean by that? So here's our Ferris wheel. Let's say here's where you get on. We want to know how many degrees you travel every single minute. So taking a look at the information, they tell us that the rotation speed is 16 minutes for 1 revolution. In other words, it takes 16 minutes to get all the way around the Ferris wheel. So I can write that as a fraction. So it takes 16 minutes to go 1 revolution. So since I want to know the angle of rotation per minute, instead of writing 1 revolution, I know it's 360 degrees for an entire revolution all the way around. And I want to know how many degrees I'm going per minute. So instead of 16, in order to get 1 minute, I need to divide by 16 to get 1 minute, right? So if I divide the denominator by 16, I would get 22.5 degrees. So 22.5 degrees every single minute. So for this last part, we're trying to find the arc length in terms of pi, where Rennie will be at in 1 minute and then in 5 minutes. So we'll start with 1 minute. So for the arc length, we're setting up our two equal ratios. The first one is talking about arc measure. So in 1 minute, he's traveled 22.5 degrees. That's what we found out. Out of a total of 360. And that's equal to what we're trying to find, the arc length out of a total of, for the circumference, 2 pi times the radius. And in this case, to find the radius, we know that the diameter is 100. So all the way across is 100. So to get the radius, we just need halfway across, right? So the radius is 50. So when they say in terms of pi, they mean your answer will still have the pi symbol in it. So I'll show you what that means when we cross multiply. So in order to find x, I would do 360 times x, which is 360x. And when I multiply my next numbers together, I'm not going to multiply 3.14 for pi. All I'm going to do is multiply 22.5, the 2, and the 50, which 2 times 50 is 100. So 22.5 times 100 would be 2250, and then you still have that pi symbol there because you didn't multiply 3.14. So the last step is to divide both sides by 360. So ignoring pi, you're just going to take this and divide it by 360. So 2250, divide that by 360, and you get 6.25. So in terms of pi, it would be 6.25 pi. And if you want the full answer rounded to the nearest tenth, you would multiply 6.25 times 3.14, and you would get your final answer. So for 5 minutes, I'm going to set that up over here, two equal ratios. So in 5 minutes, how many degrees has he traveled? Well, in 1 minute, it's 22.5 degrees. So if you want 5 minutes, you're just multiplying that by 5, right? So if you multiply 22.5 times 5, you get 112.5 degrees. Out of a total of 360, we're trying to find the arc length, so x, out of a total circumference of 2 pi times the radius, which is 50. So grabbing a calculator, cross multiplying, I would do 360 times x, which is 360x, and that's equal to, so again, you're ignoring pi and you're just multiplying 112.5 times 2 times 50, or 112.5 times 100. And you would get 11,250 pi. One last step is to divide both sides by 360. So again, you're just taking 11,250 and divide that by 360, and you get 31.25 pi. So that would be part B here, 31.25 pi.